Hi everyone, welcome to my channel Code with GT. I am Gaurav and I have been working as a software developer since the past 5 years. I create videos to help you become a better developer. So without further ado, let's dive right in. Hi everyone, welcome to the first video of my playlist Must Do Coding Interview Questions. We will start with the first question, which is the maximum subarray problem. Let's look at the problem statement first. Let's say we are given an array. I will pick the array values from here. The question states that you are given an array. You need to find a subarray which has the maximum sum. So the first part is you need to know what is a subarray. Well, a subarray is defined as a part of the array that is continuous. So for example, in this array, this -2 and 1, this combination is a subarray. -2, 1 and 3, this is another subarray. Now -3, 4, -1, this is also a subarray since this is part of the bigger array. Now what is not a subarray? So suppose if you pick up -4, 2 and 5, -5, like this will give something like 4 to -5. This is not subarray. Now picking individual elements from an array to create a smaller set of numbers is called a subsequence. So this 4 to -5 is a subsequence, but it is not a subarray. Now a subarray can be a subsequence. I can take, for example, 1 -3 and 4, 1 -3 and 4. This is a valid subarray and this is also a subsequence, because a subsequence is defined as any set of elements which you pick up from the array. Now that we know what a subarray and subsequence is, let's look at the problem statement. We need to find a subarray that has maximum sum. So in this case, if I start taking a subarray, say -2 and 1, its sum is -1. We can also look at -2, 1 and -3. Its sum is -4, and we can also take 1 -3 and 4. Its sum is 2. Among these three combinations, the maximum sum is 2. We need to find all possible combinations of subarrays that can be created from this bigger array. Applying some combinations logic, we know that the number of possible combinations will be n square for this. Pick up the first element and you can create, let's say the size of this array is n. You pick up the first element, -2. How many subarrays can you create from this? You can create this 1, then this 2, 3,
4, 5, 6, 7 and 8 subarrays.
And what is the length of this array? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can create n-1 subarrays from this. Now if you start from 1, you can create n-2 subarrays from this. This will go till n minus the last element, which will be n minus 1, which will be 1. So if you start from -2, you got n-1 combinations. Starting from 1, you get n-2 combinations till the last element, where you get only one combination. So if I add all of these, I get something like
n-1 plus n-2 plus n-3 and so on till 1.
Now this is similar to a maths problem where if you sum all of this, you will have these many number of combinations, which is n square minus n by 2. So you can see the highest possible order is n square. Going by this method of like taking into account all subarrays and finding the maximum sum will give us order of n square. This is our brute force solution. Okay, so let's code for this now. We find the size of the array, and then we will declare a variable int max subarray sum, which will be, I will take it to be the first element. I'm assuming the array won't be empty, and it's a good assumption as we are always comparing, and if we find a value greater than this, we will update the value of max subarray sum. Now we run a for loop for int I is 0, I less than n, I plus plus. Now this will be the starting point of our subarray. We declare a variable sum as 0, and we will add another for loop which will be the end of our, which will take I as the initial starting point, and it will go till all the elements till the end, which will basically be our subarrays j plus plus. We will add each value to sum, and
then
we will compare that value with our max subarray sum variable, and at the end we will return this. Let's run. All the test cases were passed. Now let's try to submit. We got a time limit exceeded error since this test case is very big. Clearly this is not an optimized solution because this runs n times, this loop will run n times. Our time complexity is order of n square. So here Kadane's algorithm comes into play, which provides a more optimized solution which runs in order of n. Since the earlier solution gave us time limit exceeded, let's look at a more optimized solution, which is Kadane's algo. We will solve this in order of n, which means we will traverse the array only once. While traveling the array once, we need to list down what information do we have at that point. So for example, we take this example, we have -2, 1, -3, 4. At this point -2, we assume a new subarray has started from here, and the max subarray sum will be -2 here. And also, since we started a new subarray here, we will have another field, current subarray sum, that will also be -2. Now as we move to the next element, we reach 1. At this point, we check what the current subarray sum is. We see it was -2. Now anything we add to -2 will decrease the value, like this will always be less than x. So let's say it's a negative number, my sum will be -5, let's say it's a positive number which is 1, the sum will be minus 1. So at this point we take a decision that since the current subarray sum was negative, we will end the previous subarray and start a new subarray from here. So at this point we will update the current subarray sum to 1, the current value, and we also do a comparison at this point. Like at every node we will need to do a comparison to update this max subarray sum. Max subarray sum is maximum of current subarray sum and the already present max subarray sum, and in this case now this gets updated to 1. Let's move to the next element, which is minus 3. Now we check what the current subarray sum was. It is greater than 1, so we accept it and we go 1 minus 3 will give minus 2. So the current subarray sum now becomes minus 2, and we again do this check, max subarray sum, max of current and max, and the max subarray sum till now was 1, so we don't update it because 1 is greater than minus 2. We go to the next element, which is 4 in our case. Here we check what the current subarray sum is. We see it is minus 2, so we straight away reject it and start a new subarray from here. So we update it to 4. At this point we check we check this condition, max of current and max subarray sum, 4 is greater than 1, so we update this to 4. Next we go to minus 1 and we repeat this entire process, and at the end we need to return this result, because at every element we are checking what the max subarray sum is. So this way we get our result, and we only need to traverse the array once. So this is called Kadane's algorithm, and let's code for it and it will be clearer. Let's now code for Kadane's algorithm. As per the design, we will have two variables, max subarray sum and current subarray sum. Let's go ahead and define it. I will pick up this, I will by default assign the first element of the array. This will also be the first element. Since initially we had minus 2 and both of these were minus 2, so it's fine. Length of the array is now we will write our for loop here. I will start from the first element since the 0th index is already covered here. Going back to our previous design, when we reach an element, we check if the current subarray sum is greater than 0 or less than 0. So we write the condition here. If this variable is less than 0, we assign a value of 0 to it. Now if actually we assign the current element. Now you can do it both ways. You can assign it 0 and then add the new element later, but since we discussed it this way, let's continue. If the current subarray sum is not less than 0, we will add the current value to the subarray. Now after all this, we will use this condition to compare and update the max subarray sum. So our max subarray sum equals math.max. By mistake it got compiled, it's fine. Nums, yeah, it will be nums dot length, yeah, math.max of current subarray sum and our max subarray sum. At the end we will return the max subarray sum. Let's run it. Yeah, so all the test cases are now passed. Let's proceed to submit our code. And this was the optimal solution, Kadane's algorithm. Thank you for watching. If you liked the video, hit the like button and share this video with your friends. Subscribe to my channel Code with GD. Till then, happy coding. Bye bye.